4.6 undetermined coefficients as we did in previous sections, but here we're going to use the annihilator approach. So what is the basic idea here? We're going to find YC complementary solution. For this applies for homogeneous differential equations, and we find YP, the particular for non-homo. And this method we're going to be using, it works on equations with constant coefficients as in the past we did. And the easiest way to see this, how we use annihilators to solve differential equations, we start with an example. This example asks us to solve d squared y dx squared plus 4y dy dx plus 3y equals 4x squared. So to start with this, we look on the left hand side and write the characteristic equation. M squared plus 4 m plus 3 equals to 0. This can be factored. M plus 3 m plus 1 equals to 0. So you get m equals negative 3 or negative 1. So then the YC is C1 e negative 3x plus C2 e negative x. That's YC. Now, to use the annihilator to finish with this, we annihilate 4x squared by multiplying both sides by the same differential operator. Same differential operator. Now for the 4x squared, the annihilator is d cubed. That would make it, since d cubed of 4x squared or 4d cubed x squared, this is 0 by the previous section. So if I look at the equation, differential equation, I'm gonna translate that the y's double prime into d squared plus the y prime 4d and then 3 times y equals 4x squared. Now what we do is we take apply or multiply both sides by d cubed. So this side, the right hand side is 0. This one becomes, think about it as the characteristic equation again. This is m cubed times m squared plus 4m plus 3, and this equals to 0, as you can see. Then this is m cubed, m plus 1, m plus 3 equals to 0. Then we solve m equals 0, 0, 0, negative 1 or negative 3. Then the general solution from here, y general, is c1 plus c2x plus c3x squared for the first 3 zeros plus c4 e negative x plus c5 e negative 3x. This is the YC that we found earlier, and therefore this is the YP, the particular solution. For the particular solution, we need to determine the coefficients C1, C2, and C3. So how do we do so? We see that this particular solution is a quadratic, so we can take y particular to be a plus bx plus cx squared. Then y prime p is b plus 2cx. Y double prime p is 2c. And now we substitute all this into the original equation. Substitute into the given differential equation. So what do we get? We get 2c plus 4b plus 8cx, 3a, 3bx, 3cx squared equals 4x squared. Now we group like terms in a way the constants together, 3a, then the x is 8c plus 3bx together, plus 3cx squared together equals 4x squared. And we set them, this equals nothing there, 0. So 2c plus 4b plus 3a is 0. We compare coefficients. 8c plus 3b is also 0. And 3c equals 4. So c is 4 over 3. Then you can substitute this back in here for b. I got b negative 32 over 9. And you substitute both back in here to solve for a. And a is 104 over 27. So then the particular solution becomes a is 104 over 27. B is 32 over 9x. And c 4 over 3x squared. And then you can put it back in to get the general solution. That's how we use Annihilator to solve differential equations of this kind. Another example, solve y double prime plus 4y equals 4 cosine x plus 3 sine x minus 8. So we start with the left hand side, m squared plus 4 equals 0. M is plus or minus 2i. Then the yc is basically c1 cosine 2x plus c2 sine 2x. That's for the left hand side. Now the right hand side, we need to see what the annihilator is going to be. This part has annihilator d squared plus 1 because alpha is 0 here, if you remember previous section, beta is 1. So d squared plus 1. And for this one, the annihilator is d itself. So then the annihilator for the whole thing is their product by the previous section. This means we're going to multiply both sides of the equation by the d times d squared plus 1 after converting the left hand side into d squared plus 1, 4 plus 4 y equals 4 cosine x plus 3 sine x minus 8. So what do? We multiply both sides by the same operator, d times d squared plus 1, d times d squared plus 1. And what do we get for this? Convert that into m squared plus 1, m squared plus 4, and the right hand side automatically 0. So then I got m equals 0, m equals plus or minus I, m equals plus or minus 2i. Y general is c1 cosine 2x, c2 sine 2x. That's from this part. And then from this part, we have c3 cosine x plus c4 sine x. And for the last one, this one, the 0, is c5. That's the general solution. Now, if we would like to find here we have the first part is yc and the last part is y particular. So if we need to find c3, c4, c5, the way we do it is that y particular is written in the form a cosine x, b sine x, plus c. Y prime p is negative a sine x plus b cosine x. And y double prime p is negative a sine x minus b sine x. This is cosine x, sine x. And then we substitute them in 3a cosine x, 3b sine x, plus 4c equals 4 cosine x, 3 sine x, after substituting to the original equation. Equating coefficients, you get a to be 4 over 3, b equals 1, and c equals negative 2. So the y general becomes c1 cosine 2x plus c2 sine 2x. A is 4 over 3 cosine x, b is 1 sine x, and minus 2. All the questions follow the same procedure.